Hey everybody, welcome to another Con Support video. This one is on graphing proportional relationships. Let's go. All right, so let me zoom in a little bit here. All right. It says Tara takes her pulse in order to determine her resting heart rate, measured in beats per minute, BPM. She takes it for 3 minutes and makes the following chart of the results. We'll assume that Tara's heart rate is constant over the 3-minute period. So 60 beats for every 1 minute. So the unit rate is 60, so it's 60 beats per minute. So we want to graph that on this table here. So graph the proportional relationship described above, where the x-coordinate represents the minutes and the y-coordinate represents the beats. All right, so basically when x is 1, y is 60, right? When x is 1, y is 60. So when x is 1, y is 60. So that's one example of the answer, which means that the other point could be anywhere in that relationship. And since I can't go up to 2 and 120, I'm going to just cut that in half. So when x is a half, y would be 30. And an a-proportional relationship should be a straight line that goes through the origin. Is it a straight line? Yes. Does it go through the origin? Yes. And that's it. That's how you do it. Okay, graph the line that represents a proportional relationship between d and t. The property that an increase of 5 units in t corresponds to an increase of 2 units in d. So basically the ratio of 5 units in t corresponds to 2 units in d. I would probably think that would be distance over time, so I would think 2/5 would be the slope, but let's read a little more carefully. What is the unit rate of the change of d with respect to t? Yeah, so it's d over t. So in this case, it's going to be 2 units for d and a 5 units for t, so it'd be 2 over 5. So we're looking at y equals 2/5 x, but because of the fact that it's d and t, it would be d with respect to t, so it's going to be d is equal to 2/5 t. That is a change of 1 unit. Okay. All right, so basically we got to graph that. It's just 2 for d and 5 for t. So 2 for d and 5 for t. So 2 for d and 5 for t. So when t is 5, d is 2. So that's your first dot, right? When t is 5, d is 2. And then any other relationship where that ratio stays the same. So x is 5, y is 2, basically, or t in this case is 5, d is 2. So 5 comma 2 is the same as what? 10 comma 4, right? But I can't go there. It's too far for me to go. Can't plot it. So let's cut this in half. So half of 5 would be 2.5, and half of 2 would be 1. So it'd be 2.5 to 1. That's going to be all lined up and going through the origin. So 2.5 to 1 is the same as 5 to 2. So the ratio of basically d to t, or d over t, is always going to be 5 halves. And that means that as t becomes 2.5, sorry, not 5 halves, 2/5, right? So as t becomes 2.5, the d is going to be 1. As t becomes the 5, the d is going to be the 2, because the ratio is 2/5, right? So the unit rate is going to be 2/5, right? And that's going to be your multiplier. If I wrote an equation for this, it would be d is equal to 2/5 times t. And that's what this graph would look like, right? When t is 1, d is 2/5. And you can see that's where that would be. All right, the next one. Okay, y equals 2/3 x. This one's really easy. So this is just the ratio of y over x, 2 over 3. So that means your ordered pair is going to be 3 comma 2, right? So when x is 3, y is 2. And then the ratio has to stay the same. So when x is 3, y is 2. So when x is 6, y would be double 2, which is 4. And that's going to be a straight line that goes through the origin. And that's the equation. That's the graph. So which of the following statements is true? Choose all the answers that apply. The equation represents a proportional relationship. Yes, that's true. The unit rate here is 2/3. So let's see if that's correct. The unit rate of change of y with respect to x is 2/3. Yes. The slope of the line is 2/3. Yes. The slope of the line basically means the unit rate, right? Is the unit rate 2/3? Is the multiplier 2/3? Yes. A change of 3 units in x results in a change of 2 units in y. So if x is increased by 3, is y increased by 2? Yes. And then a change of 3 units in x results in a change of 1 unit in y. If I increase the x by 3, do I increase the y by only 1? No. Every time you increase the x by 3, you're increasing the y by 2. So this is not correct. Everything else is good. All right, a proportional relationship is shown in the table below. So when y is 1, x is 1.3. When y is 2, x is 2.6. So basically, when you're looking at this ratio of y over x, it's going to be 1 over 1.3, which is the same as 10 over 13. So it says, what is the slope of the line that represents this relationship? It would be 10/13, 10/13, because if you take the 1.3 and times it by 10/13, you're going to get the 1. And how did I figure it out? Because the ratio of y over x is 1 over 1.3, and an equivalent ratio to that would just be 10 over 13. So here we're going to go when x is 10, 10 over 13. So when x is 13, y is 10. So when x is 13, so 10, 11, 12, 13. When x is 13, y is 10. So when x is 13, y is 10. Let's go up for there. That's a funny thing. Why is that a straight line? Oh, I know what I'm doing wrong. Well, so sorry guys. So when x is 13, y is 10. So here's 1, 2, 3, 13, and y is 10. There we go. Yeah, that's 1, 11, 12, 13. Yeah, that's going to be fine. All right, and then you got to find an equivalent ratio to that. So if you cut that in half, top and bottom, you're going to say that when x is half of 13, which is 6.5, so 5, 6.5, then the y value will be 5. So that will be your second dot, right? So when x is 6.5, y is 5. And now it's going to be a straight line that goes through the origin. Remember, every proportional line is always a straight line that goes through the origin, so it should line up and go through the origin. And the slope of this line is 10/13. As the x is increased by 10, the y is increased by, as the 10/13. As the x is increased by 13, the y is increased by 10. So as the x is increased by 13, the y is increased by 10. So as the x is increased by 6.5, the y is increased by 5, and that ratio stays constant. So that's good. Yeah, that will work fine. All right, and that's how you do that problem. All right, hopefully that helps.